by talking about the project and seeing what we can come up with for what it's asking us to do and our best approach to it. So what have y'all discovered so far?
So it says is we need to have an at-rest state.
Okay, so, well, we need, yes, we need to have at least one at-rest state. We might want to have different at-rest states that.
Right, that's what I was wondering.
If when I do this project, because I'm going to do it, I will have multiple at-rest states.
Okay, so for each floor.
I'll have
Okay.
one for each floor,
Yeah.
yeah. I think that would be easiest, because what I have learned in the past is you can do things by having fewer states and more code, but Verilog doesn't like that. Verilog wants you to have states. It's like it knows how to do that, and the code, it's like it just doesn't always work the way you expect it to. So I go with more states. It might seem like it's longer at first, but then once you program it, it works.
Right.
So yeah, so we know that we will need, at this point, at least one rest state for each floor. What about the different floors? So what's the behavior? So how does this, like, let's talk through like a day in the life of this elevator. Let's say that we had let's say we went, so right now I'm just thinking, these are not states, these are just actual floors. So, 1, 2, 3 floors?
Yes.
Okay. So, first, what's our reset gonna be, or what's our entry gonna be? Or do you want to have it, you could also set, like to have a load, so you could say, start on this floor. I think it's probably easiest just to have a reset.
Okay.
But, but you could do it however you wanted to do it. So, let's just say our reset state would be, like, well, what would it be? So, I would say, like, for debugging, probably floor 1,
Right,
Yeah.
like the at-rest floor.
the at-rest floor 1.
Mhm.
And so that would also be reset. Actually, I can see the computer better.
Oh, if you'd rather that, we could do like that.
Do you want the light or?
I don't need it.
Okay.
Do y'all
Yeah,
need
it's
it?
fine.
Yeah,
Yeah,
that's
it's
good,
fine.
yeah. And I think we'll have to get more sleep in the back of the room. Okay, all right. So let's say we're at rest on floor 1, and it says to use switches for the call buttons, right?
Yes.
And it gives you like specific switches to
Yes, it
use?
does.
Okay, and what were these switches?
So it's like 1, 2, 3 for the respective like floors, like calling
Okay,
the.
1,
do you know what I
2,
mean?
3,
Yeah, and then the other one is 5.
That one's
5
for holding the door open.
Yeah.
for holding the door open.
Yes.
Okay, and does anyone remember, are the switches numbered from right to left or left to right on the board?
I don't really know which way this is.
Yeah,
supposed to
that
be.
one doesn't help me because that's just the diagram. Is this the manual?
Yeah.
Can you scroll through, because it'll,
Yeah, like up.
like
all
there's
the
a
way up.
picture somewhere, like an actual
Let's
photograph.
see if it's. Let me just scroll all the way up.
Yeah, there it is.
Okay.
And like just zoom in on it, like real big.
So this is, it's like this, so it's 1, 2, 3.
Is the first one 0?
Yeah, this one's 0.
Okay.
This would be the opposite.
So we have 0, so we're not using that one. 1, 2, 3. and then 5?
Yes.
Okay, so that just helps me kind of picture it.
Mhm.
Okay, so let's say now that we turn switch 3 on.
Mhm.
What do we expect the next state of the elevator to be?
2.
Okay, now, we know it would have to go, it takes 1 clock cycle to go to each floor, so it would go to 2. And would our output, we have 2 outputs, we have the 7-segment display, and we also have a door open light, I think? Yeah. Okay, so when we go, the next state, so we're currently at floor 1, so that would be, our 7-segment display would look like that, and our light would be off. And then we would go to floor 2, and would our light be on or off?
Off.
Off. And then we would go to floor 3, and then would the would light be on or off?
On.
And then it would be on. And then what would happen after that? So let's just say there's no more switches set.
We'll be at rest on floor 3.
Well, there's something else in the instructions. So it's not, can't be at rest yet.
That's what it-
It might be somewhere else, let's see.
Oh, I see. So it's saying like
Yeah, there
it
it
should.
is.
The
Remain,
door should open, remain on this floor with the door open for a small amount of time, and then it should close.
yeah, and I think it's more specific about that somewhere else, let's see. Oh, here it is. Yeah, just keep reading to the end of that,
Okay,
that
this.
longer bullet, yeah.
So assume the elevator takes 1 clock cycle to travel from one floor to an adjacent floor, and that the door stays open for 2 clock cycles.
So, and at the at-rest state, what is the door supposed to be?
It should be closed in an
Yeah.
at-rest state.
Yeah. So, before it can do anything else, when it first arrives at the floor with the door open, the next state is always going to have to be the same floor with the door open, because it has to stay that way for at least 2 clock
Okay.
cycles. Now, it was not clear to me if it needs to be like 2 clock cycles, or do we need to have yet another clock cycle, because
Right.
it just
That's
arrived
what I was
here.
thinking.
And so I've always done it like this,
Okay.
but,
I mean,
'Cause
I
if we
think
said-
that does make sense as
Yeah.
well. I guess it just could be interpreted.
I think you could interpret it different
Yeah.
ways, and I think if you interpreted it the other way, when you're, demonstrating it, and you say, this is the way I read it.
Right.
So I think that would be fine, because it is certainly a valid interpretation, one way or the other. Okay, and then if no switches are set from there, it would go to floor 3 with the door closed, and this would be the rest state. And if nothing happens at this point, it would stay in a rest state. So we know that whatever rest states we have when we get around to like doing our diagram, if these are our rest states, 1 rest, 2 rest, and 3 rest, we know that if all our inputs are 0, so 0, 0, 0, 0. How many inputs do we have? Just 4?
Yeah, 4.
If all our inputs are 0, it's always just going to stay in the rest state, so we know that. So, and we also just learned that we have, if we're going to, and you don't have to do it this way, I learned, for me, I think it's easier to do it this way, to have separate states for door open and door closed, because they have different
Right.
outputs. So if you're going to, the state for when you first arrive at a floor, that you don't have any choice other than to go to another state that has the door open.
Right.
And those are going to need to be different states, because this state has to go to that state, but this state could go to other places. So this is going to be just a don't care on each of these. I'm calling them floor 1 and door open, and floor 2 door open, and floor 3 door open. And you can think about all of the different places you could go from that state. Let me make this neater now. And just so as to not be confusing, the door is also open on these first 3 states. On the arrival state, the door is open when it arrives. Although I have had people interpret it differently, that they have a state when it arrives,
And the door.
and then
Yeah.
the next
And
state
then
it's
it'll
open, and then the
Okay.
next state it's open.
Okay.
Do you see?
Okay.
Yeah.
Oh, because it needs like the 2 clock cycle, or why?
Right, so
is that
what
why?
they did is they said it takes a clock cycle to get to the next floor,
Right.
so that's the
Okay.
first clock cycle, and then the next clock cycle it opens the doors, and then the next clock cycle it has the doors open again.
Right.
I've never done it that way, and most people haven't, so,
Okay.
so I don't think that's,
Yeah.
yeah. But, I mean, so, and we had, this was a don't care. Actually, I'm going to write don't care, don't care, don't care for all 4 switches. So I'm going to, and let's say what our switch, what these numbers are referring to. Let's have them refer to, put them in order for switch 5, 3, 2, 1. So that's what those are. And so while I'm here anyway, no, that would not be true. So this is just going to be 0, 0, 0, 0. Yeah, 0, 0, 0, 0. Okay, what's the first switch is to keep the door open? Is that what the first switch is?
Like 5, you mean?
Yeah.
Yes. So, but that's like to say the door's already
The door's
open,
already open.
and it holds it open.
Right. So if the door's already open, if that's required in order for that to happen, then right here, the door is closed. So we would have a don't care here. So this would actually be don't care 0, 0, 0. Because since the door's not already open, it can't open. And so if you're on the floor, if you just, don't get off the elevator and you're in the first floor and the rest state, if you want the door to open, you have to press the first floor.
Right. Okay. That makes sense.
All right. So we know that we could get here if we had, well, I would get here by having 1, don't care, don't care, don't care.
Okay.
Does that make sense?
Yeah.
Because you want to keep the door open, but you don't want to go back to this state because you're not saying I have to keep it open forever, I just have to keep it open right now. So So to go from here to floor 1 rest, we definitely would have to have a 0 for the hold button, because if that's 1, then we're going to stay here. We'd have to have a 0 for the 1, because otherwise, again, we'd keep the door open, and also a 0 for 2 or 3, because otherwise we'd go to those places.
Right.
So this one has to be 0, 0, 0, 0. Okay, so I'm going to go to the 2 rest state, and I want to think about all the things that could happen here. We have only taken care of 2 of the 16 different possibilities, because we have 1, 0, 0, 0, and 0, 0, 0, 0 say it's going to stay here. So but we have taken care of we have taken care of those. Okay, so let's start by saying, what do we want to do with the action of the other 3 switches? So, like for instance, what if they're all 3 turned on? What should it do? The way I would say is, let's picture you're actually in the elevator.
Right.
And you're in the elevator, you're on the 2nd floor, people got out ahead of you, you just were letting them go, and then the door closed. And now you're in the rest state. You're like, okay, I want to get out, you press 2, but someone else is in the elevator, I need to go to 1, I need to go to 3. Okay, what should it do first?
Open it
Oh,
too.
yeah.
I would think it would open it
Yeah,
too.
yeah,
If I'm
for
sitting
sure.
there, I would think it should open it too. So I think that it should go to here.
Oh, I see, because it's not, yeah, it doesn't need the arrival, it's already there.
I think so, right?
Yeah, that
I think
makes
so.
sense.
So I think that it's a don't care on the hold button, and it's a don't care on the 3, and a 1 on the 2, and a don't care on the 1. And so that has taken care of 8 of our 16 different states. Now we've taken care of 10 of our 16 states. So now we need to think about what happens with the 1 and the 3. So it seems real clear to me, if it's just the 1, then it should go to floor 1. And if it's just the 3, it should go to floor 3.
Mhm.
So if we have and if it's the 1 and the hold, the door's not already open.
Yeah,
The hold,
if it's
hold
a-
button's only supposed to work if the
Yeah,
door's open.
Exactly.
So that would be, so this one would be if I have floor,
Oh,
floor 1 is 1, 2 is 0, 3 is 0, and we don't care about the hold because the hold is irrelevant because the door is not open right now. So this would be don't care, 0, 0, and 1. Does that seem right?
Yeah, that makes sense.
And then similarly, if just 3, that would be don't care 1, 0, 0. So now the only thing we have to do is to decide what if 1 and 3 are both pressed.
So we can decide that, basically?
Mhm.
Okay.
Yep. And I would say in this instance, since it's at rest, it's not like it was on its way anywhere.
Mm-hmm.
So I think you could just pick one. Yeah. So whichever one we pick, we can change that one right now where we have a 0. Like if we say floor 1 has priority, we can change this 0 to a don't care. And then we will have taken care of all of the different possibilities. So I'll do that. I'll pick floor 1 to have priority. And now we want to check and make sure that we have taken care of every possible combination of switches that could occur from this floor. So we have, what we have is don't care 0, 0, 0. We have don't care 1, 0, 0. We have don't care 1, no, don't care 0, 1. We have don't care 1, don't care. Did we have anything else?
No.
Okay, so have we taken care of all of the possibilities when floor 1 is 0? Yes, because, like, just like, let's just think about our 16 different numbers. And I have an advantage because, I've done this sort of thing before.
I feel like I need to visualize heads.
Yeah.
Just to
Yeah.
see.
I think that's what I realized when I
I
was looking
know.
at it. It's like, I realized that I knew it, but it's like, I have done this before, so let's see.
Oh.
Yeah, that helps.
Yeah. Okay. All right. So let's just pick one and see, is it covered by one of these cases? So the zero's fine because I have all those don't cares. Do I have one of these will match with 1, 1, 1, 1, and actually that only one of those will match with 1, 1, 1, 1?
That last,
Yep.
the last one.
Yep. Okay. So why don't y'all spend some time looking at it and seeing, verify for yourself that, yeah, all the cases are covered and that none of the cases could potentially go to more than one of them. Because that's where Verilog, or that's where Vivedo will say, have problems.
Right.
And
Yeah,
and
it's neat.
yeah, and it's kind of crazy that it worked
Yeah.
out, because I kept thinking, well, surely there's gonna be one that'll fall into more than one, but
No.
there wasn't. Okay, so now let's look. I think, having done this before, that our choices for floor 2 door open are going to be very similar to what we just had right here, because it can still go everywhere.
Right.
And so the only things that are going to be different are going to be anything that involved the fact that it was at rest. So because the door is open here, the hold button does something different, but we've already gotten that one taken care of. So we already have, if the hold button is open, that's going here. But assuming the hold button is not open, that means that all of these become 0. Because we took care of when it was 1 already. We said that was 1, don't care, don't care, don't care. And so when all of these are 0, we would probably have the same behavior. We've already taken care of this one. That one's already done. And then 0, 1, 0, 0, that went to floor 3. Do we still want 0, 1, 0, 0 to go to floor 3? Yeah, I think so. Yeah. Do we still want, I can go to the bottom one, do we still want 0, don't care, 1, don't care, to go to floor 2, door open, to go back to itself in this case? So the way I picture this is I'm in the elevator, the doors are starting to close. I want to get off on floor 2 and I can't figure out what button to press, and I press 2. It still ought to open up for me.
Right, right,
Yeah.
right. That makes sense.
So that would be 0, don't care, 1, don't care. And if we follow the same logic that we did before by saying we're going to give floor 1 priority, that if 1 is selected, we don't care if 3 is selected, then 0, don't care, 0, 1 would go to floor 1. So, we're 1/3 of the way done, more than 1/3. We've got all of floor 2 is taken care of. So now let's start with, y'all want to go to floor 1 rest or floor 3 rest?
Doesn't matter, we do 4-1.
Okay, so we'll go to floor 1 rest. I'm gonna delete these over here. So what kind of behavior do we want to have? Is there anything that you know that anything like based on what we did with floor 2 that we know we're going to want to have?
So I'm thinking if you're at floor 1, it's at rest, and you press floor 1, it would go to the first arrival state.
That's what I would expect. Not the arrival state or the door open state?
Oh, the door open state, yeah.
Okay, because we decided that
I didn't need that.
we didn't need that,
No.
yeah. So that would be, we don't care about the hold button, and we don't care about floor 2 or floor 3, but if floor 1 is 1. Now, if floor 2 and floor 3 are both selected, this time, does it make sense to give one of them priority over the other?
Yeah.
So if floor 2 is selected and floor 1 is not, then it should go to floor 2 regardless of what floor 3 does. So that should be,
Does that need another state or does it?
we are gonna need another state in a
Right.
minute. So this is floor 2, but we're stopping at floor 2.
Okay.
Yeah, so this one is gonna be, we're going to floor 2 and somebody's getting off at floor 2, someone selected floor 2. So this is, we don't care about the hold button, we don't care about floor 3, we have a 1 for floor 2, and we have a 0 for floor 1.
Okay.
We also will go here. Yeah, so we have the don't care for floor 3. So we'll go here whether if floor 3 is on or not. So that'll happen. So now we just have to take care of what we're going to do if we just have floor 3 selected. It can
Okay.
only go to one floor per clock cycle. So it's going to go to floor 2, but it can't go to any of these states because if nothing else is selected, it should continue on to floor 3. So I'm going to do this one way and you may decide that you want to do it an easier way. So I'm going to have another state here that I'm going to call floor 2 going up with the door closed. And that would be if I don't care about the door open. I have a 1 for floor 3. I have a 0 for floor 2 and a 0 for floor 1. So my only question here is what are you going to do with this state? The easy thing to do with this state is to say, put a bunch of don't cares on it and have it go to floor 3. So you could do that. But remember, there is a clock cycle there. You press the button. Someone could, at that point, change the switch and say, I want to go to floor 2 now and not to floor 3. So you could say, no, you're stuck. You have to do that. You can't do anything but go to floor 3, but that's not the way I'm going to look at it. So I'm going to say, once I get here, I said we were done with floor 2. We're not really done with floor 2. This one, I think, would do exactly the same as this one, as the floor 2 at rest. Doesn't that make sense?
Yeah.
Because let's say you get there and someone turns off the floor 3 light. I mean, the call floor 3.
Yeah, then it wouldn't need to go. Yeah, that's interesting because I guess in real life that doesn't happen that way, but you can do that on the board.
I don't think they'd ever test that. I mean, I just
Yeah.
like to think of every possible scenario because it's the scenarios that I don't think of that Vivedo says, well, yeah, but what if you have to be on floor 1 and 3 at the same time?
Right,
But,
right.
so I guess the one question I have is if you're here and there's no switch set, should you go to the door open? Or do you want to just be trapped in the elevator?
I would just, well, I don't know.
Wouldn't it just continue up to floor 3?
If
Yeah.
you could, you could do that. I'd say if no floor is set,
Yeah.
if somebody cancels the floor 3, you say, I was on my way anyway. I was just wondering about, because we had the don't care 000
Right.
there. Because I was thinking, like, what are we going to do that would be different from floor 2 at rest And I think everything we would do would be the same, except for maybe that one. Because theoretically, what is likely to happen is if you actually had this scenario, you would be on floor 1 and the lab TA would say, okay, well now do floor 3. And you'd press the button, and then you'd press the button again, and you'd be on floor 3, and that would be all that would happen. I mean, I don't see him saying, okay, well, you've pressed the button once, but now you've changed your mind, change all the switches. you know,
Yeah.
you know. So
I
for,
guess the thing is, yeah, because like the input to that, you do have 0 for switch 2. I guess it's like going into that state, you're assuming you don't need to open that 2,
right,
right?
right,
Like,
because that
what
doesn't
you're
happen when
saying.
you, I mean, if you're in the elevator and it opens on every floor, you get pissed off. So what is likely going to happen is that it ends up here, but I think that would be don't care. Um, 0, 0, 0, or really don't care 1, so it really don't care 0, 0.
Okay. Right, that makes sense, because you already have the 1
Yeah.
going in.
I'm just going to put outward behavior. So all the same arrows that we have for floor 2 at rest, we'll have for this one, floor 2 going up. And knowing that, we now know what floor 2 going down is going to look like. It would be the same idea coming from floor 3.
Okay.
So that arrow would go all the way over to floor 1 arrive.
Okay.
And I'm saying everything else would be the same as floor 2 at rest. And then floor 1 door open is going to be the same as what we just did for floor 1 at rest. Just like floor 2 door open was the same as floor 2 at rest, with the exception of the, what did we add here? If you press the floor 1 button and you're in floor 1 with the door open, we said you should stay there.
Okay.
So this would be 0 for hold door, don't care, 1. And then we would have zero, don't care, 1, 0 comes to floor 2, arrive. So we have 0, because the hold, if the hold is on, it stays on floor 1. We don't care if floor 3 is selected, because floor 2 is selected, so that's a 1. We have a 0 for floor 1. And then we go to floor 2 going up. If we have a 0, a 1, a 0, and a 0. I would like to pause for a minute and make sure that we got everything for this state. So the floor 1 door open, and let's see. So let's look at all of the behavior of not getting to this state, but coming from this state. We had 1, don't care, goes to floor 1, door open. We had also 0, don't care. Oh, wait a minute. That can't be right. Oh no, there was a 1. 0, don't care, 1 goes to floor 1, door open. We had 0, 0, 0, 0 goes to floor 1, rest. We had 0, 1, 0, 0 goes to floor 2 going up. And we had 0, don't care, 1, 0 going to floor 2, arrive. So let's do another check on this one. Let's write out the 16 numbers and make sure we got them all. Or you don't have to write them out if you can look at it. I see that 0, 1, 1, 0. Nope, it doesn't. It only has one choice.
Yeah, I think that's fall into one.
It seems like it. I didn't see any problem with it.
Yeah, there's no overlap.
Yeah. All right. So I feel like, and I am usually wrong at this stage, except for the fact this is very similar to some previous ones. I feel like these are all the states we're going to need. Because floor 3 is really gonna act just like floor 1,
Right.
just go in the other
Forward,
direction.
yeah. Makes sense.
And I think that we've covered all the possibilities. So, so with leaving that for y'all to do, and for anyone who's watching this video, you know, or whoever's watching the video, you can do it some other way, because there's a lot of room for interpretation and a lot of different techniques you could use. This, you know, just kind of the way we're thinking of it here. But what would be the next steps from here? What would you do from here, besides filling in floor 3?
Like the state diagram. I mean, the state.
The state table, but the state table would be difficult, if not well, it wouldn't be
Well,
that
I guess
bad.
It would be a lot.
It would be huge.
Yeah,
Because
that's true.
what you would have would be, you'd have floor 1 arrive, and then you'd have next state, and you would have 16 columns here, but you would only have one output.
Yeah.
So the output wouldn't be that bad. So it wouldn't be undoable. So you could, you know, in this way you could, you know, make it easy to troubleshoot if you had it all laid out like that. The other thing that you could do is, rather than doing a regular state table, you could have
Oh, okay. Which that makes more sense.
like just do the same things here, and then have another column for your output.
Right.
And so, rather than having, you know, all the different conditions across, you'll just have, you know, this kind of big block in the middle that describes what the behavior is.
Yeah.
And then you would do that for each of the, how many states do we have?
I think it's 11.
Yeah.
11. I feel like there was.
We're missing something.
Let me see. No, it was slightly different last year, so that could be what it is. Let me find Digital Logic Spring 2024. Spring 2024. And it does not look like I have. It's not Digital Logic. Looks like I'm just getting started. Ooh, isn't that pretty?
Here you have another state. You have 5.
We had 5 inputs. That's what it is. We had more
Oh,
inputs.
wow.
Yeah, okay. So we don't have to worry about it.
Or was it just like another floor? Or?
It was an emergency button that would take you immediately
okay.
to the first floor.
Interesting.
Yeah,
Is that what emergency buttons do?
No.
Don't they just stop?
they just stop.
Yeah.
It's not a real elevator.
Yeah. that's
Okay,
fair.
so I think this is where I'll stop for here. So I think that gives you something. So you do your state diagram, and then if you want to, I'll probably be making some videos on how to like kind of set up your code. If you do the way we're describing here with, pretty detailed and basing everything on the states, it's not going to be much more than just like taking this and plugging it in. You're not going to have a whole lot of, well, if you do that, then you turn on the door open light, and if you do that, because it's just going to be based on the states.
Like more like case statements.
Yeah, it's going to be, you're going to have, it's going to be an always block that has the case statements that say what the next what the next state is, and then I would probably have a separate always block that says what the output is, and then a separate always block for the clock, advancing the clock.
Yeah, right.
And I am going